Now we'll discuss solutions to the assignment for week 7 on two-port parameters and reciprocity. The first question is about a two-port network consisting of control sources. This means that the network is not necessarily reciprocal, but for certain parameters of the control sources it can be reciprocal. The question is to find the value of Rm such that it is reciprocal. So all we have to do is find the two-port parameters. Specifically, we have to find only y21 and y12 or any of the 12 and 21 parameters to check for reciprocity. Okay. So first, let's say we determine y21 by connecting a voltage source V1 and finding the current I2 with port 2 short circuited. Okay. So now this turns out to be quite easy. This Vx equals V1. So this current here is 1 millisiemens times V1. Now port 2 is short circuited, so no current flows through this 4 kilo ohm resistor, and the current through this, the voltage across this is equal to V1. So the current that flows there is V1 by 4 kilo ohms equals 0.25 millisiemens times V1. So this current I2 equals this current minus that current, which is equal to 0.75 millisiemens times V1. Okay. So this number here is y21. Now we can evaluate y12 by short circuiting port 1, applying a voltage V2 to the second port and finding the current I1. Okay. So again, let's see what happens. Across this 4 kilo ohms we have V2, which means that the current here is V2 by 4 kilo ohms or 0.25 millisiemens times V2. Across this we all again have V2, which leads to a current V2 by 4 kilo ohms or 0.25 millisiemens times V2. Now this Ix here, which is 0.25 millisiemens times V2, gets multiplied by Rm. So the voltage here is 0.25 millisiemens times Rm times V2. Okay, it's Rm times Ix. Ix is this much. Now this voltage appears across 4 kilo ohms also because of the short across the second port. So the voltage this way equals that much. So the current flowing this way is 0.25 millisiemens times Rm times V2 divided by 4 kilo ohms. Okay. So the total current I1 equals the negative sum of this current and that current. Okay. So it is equal to negative of 0.25 millisiemens times V2 plus 0.25 millisiemens times Rm divided by 4 kilo ohms times V2. Okay, which is basically so this is y12. Okay, and that has to be equal to y21. So this whole thing has to be equal to 0.75 millisiemens. Okay. So from this we get Rm divided by 4 kilo ohms to be equal to minus 1 millisiemens divided by 0.25 millisiemens equals minus 4. So Rm should be minus 16 kilo ohms. Okay, so that's the answer. The next question is to determine the H parameters of the circuit that was given before. That is here after choosing the right value of Rm. Okay, so a couple of things can be done. We have already determined a couple of y parameters, so we can go ahead, complete all the y parameters and then convert them to h, or we can evaluate h parameters from scratch. So I'm going to evaluate them from scratch. By applying a current to the first port and short circuiting the second port, we can find H11 and H21. Okay, so now if I apply a current I1 to this port, the second port is short circuited, so this Ix will be equal to 0. Okay, so that means that this voltage source is 0 volts, so this is also at 0. Okay, now if you see, this is at 0 volts, this is at 0 volts, so whatever voltage V1 you have here, V1 by 4 kilo ohm flows there and another V1 by 4 kilo ohm flows there, and the sum of those two has to be equal to I1. So I1 will be V1 by 4 kilo ohms plus V1 by 4 kilo ohms. So H11, which is the ratio of V1 to I1 with the second port short circuited, will turn out to be 2 kilo ohms. Okay. Now as far as I2 is concerned, this is I2. So we have already determined that V1 is I1 times 2 kilo ohms. So this current source here is 1 millisiemens times 2 kilo ohms times I1, or 2 times I1. So we have 2 I1 over there and V1 by 4 kilo ohms, which is equal to I1 by 2 over there. So the net current I2 is given by 2I1 minus I1 by 2, which is 1.5 I1. So H21 is I2 by I1 with V2 being short circuited, which is equal to 1.5. Okay. Now for two more parameters, we have to apply a voltage to the second port with the first port left open circuited. Okay. So if we apply V2 here, this Ix will be V2 by 4 kilo ohms, and this Rm Ix, we determined Rm to be minus 16 kilo ohms. So this Rm times Ix will be minus 4 times V2. Okay. So now we have to find V1. We know that the current flowing this way is V2 minus V1 divided by 4 kilo ohms, and the current flowing that way is V1 minus the voltage at this point, which is minus 4 times V2 divided by 4 kilo ohms. Okay. So V2 minus V1 by 4 kilo ohms equals V1 plus 4V2 by 4 kilo ohms. Okay. So this goes away and we will end up with minus 2V1 equals 3 times V2. So H12, which is V1 by V2 with I1 being 0, is minus 3 by 2 or minus 1.5. Now this is a useful sanity check because we had chosen Rm such that the network is reciprocal. We see that H21 is plus 1.5 and H12 is minus 1.5. We calculated this independently. but we know that it is reciprocal and H12 has to come out to be minus H21. Okay. And finally, we have to determine I2. Okay. So we already know two components of I2, the current flowing here and the current flowing there. So we need to find the current flowing there. It's 1 millisiemens times Vx, which is 1 millisiemens times V1, because Vx is the same as V1. So this current here is 1 millisiemens times Vx, which is minus 1.5 times V2, and this is equal to minus 1.5 millisiemens times V2. Okay. So I2 is sum of these three components. This is V2 minus V1 by 4 kilo ohms, which is V2 minus 1.5 V2 divided by 4 kilo ohms, and this one is V2 by 4 kilo ohms, and this one is minus 1.5 millisiemens times V2. So this will be V2 times 2.5 by 4 kilo ohms plus 1 by 4 kilo ohms minus 1.5 millisiemens, which is equal to V2 times 0.625 millisiemens plus 0.25 millisiemens minus 1.5 millisiemens. So the answer turns out to be minus 0.625 millisiemens times V2. Okay. So H22, which is I2 by V2 with port 1 open circuited, is 0.625 millisiemens. Okay. So H11 is 2 kilo ohms, H22 is minus 0.625 millisiemens, and H12 is minus 1.5, H21 is plus 1.5. Okay, those are the answers. Now this is another network with control sources, and you have to find the value of the control source GM such that the network is reciprocal. In this case, you can choose any parameter set. Let me choose Z parameters. I have to find Z12 and Z21 and make them to be equal to each other. Okay. So first I'll apply I1 and measure V2 with port 2 open circuited. They should give me Z21. Now with port 2 open circuited, the current in this branch is 0. So Vx is 0. So this just goes away. And we see that all of this current has to simply flow in this loop because nothing can go into that one. So this Vy is nothing but I1 times 500 ohms, and this voltage is 5 times Vy, which is 5 times 500 ohms times Vy, or 2.5 kilo ohms times Vy. And this V2 is nothing but the voltage drop across this, which is this one, the voltage drop across this, which is 0, plus the voltage drop across that, which is half a kilo ohm times I1. Okay. So V2 is 2.5 kilo ohm times I1 plus half a kilo ohm times I1 is 3 kilo ohm times I1. Okay. So Z21, which is V2 by I1 with port 2 open is 3 kilo ohms. Now we compute Z12 by applying a current here and open circuiting port 1. If we open circuit port 1, the current through this branch is 0. That is the combination of these two parallel branches, that is 0. Okay, whatever is coming out of there. Then this I2 flows into this resistor to give you 0.5 kilo ohm times I2 across it. Okay, and this Vx would be basically minus I2 times 1 kilo ohm because of the polarity. So this Gm times Vx is Gm times minus 1 kilo ohm times I2. So the voltage drop in this direction, because this current is simply flowing through that, is Gm times minus 1 kilo ohm times I2 times 500 ohms or half a kilo ohm. Now this V1 is a sum of this voltage drop and that voltage drop. Okay, so V1 is, remember, voltage drop from here to there is the negative of this, so it is Gm times 1 kilo ohm times half a kilo ohm times I2 plus half a kilo ohm times I2. So this is Z12 and that has to be equal to Z21, which is 3 kilo ohms. So Gm turns out to be 3 minus 1.5, which is 2.5 kilo ohms, divided by half a kilo ohm times 1 kilo ohm. Okay, which gives you 5 millisiemens. Okay, so Gm has to be 5 millisiemens for this network to be reciprocal. Now the next questions relate to G parameters of this network. Again, we can either use the Y parameters after finishing evaluation of Y11 and Y22, or evaluate G parameters from scratch. We'll do the latter. Okay, so first we apply V1 and leave port 2 open circuited. This gives us G11 and G21. Okay, so if we apply V1 like this, first of all we know that this current has to be 0, okay, because of the open circuit. So Vx is 0, so this current source just goes away, and this V1 simply appears across a series combination of this 500 ohm and that 500 ohm, okay, because no current flows through there. So current V1 divided by 1 kilo ohm, which is a series combination of these two, flows this way, and Vy will be half of V1. Okay, and this voltage here is 5 times Vy, so this is 5 times half of V1 or 2.5 times V1. Okay, so first of all, the current here I1 is V1 by 1 kilo ohm, so G11, which is I1 by V1 with port 2 open circuited, is 1 millisiemens, and G21, which is V2 by V1 with port 2 open circuited, is this voltage here is this voltage, which is 2.5 V1, plus that voltage, which is 0, plus that voltage, which is half of V1. So the whole thing is 3 times V1 divided by V1 or 3. So G11 is 1 millisiemens and G21 is 3. Okay. Now we can evaluate the other two parameters by connecting a current source I2, short circuiting the first port, and finding V2 and I1. Okay. So now we know that this Vx equals minus I2 times 1 kilo ohms, because I2 is simply flowing through this, and this GMVx will be in this direction, minus GM times 1 kilo ohm times I2. Okay. So the current here of course is I2. Now the voltage here, let me call this Vy as is denoted there. We have a number of relationships. This current here is Vy divided by 500 ohms. Okay. And similarly, the voltage here is also Vy because of the short circuit on the first port. So the current here is Vy divided by 500 ohms. Okay. So applying KCL here, we'll get I2 to be Vy divided by 500 ohms plus Vy divided by 500 ohms minus the current through this GM, which is minus GM times 1 kilo ohm times I2. Okay. So this whole thing gives you 4 millisiemens plus GM times 1 kilo ohm, and we know that GM is 5 millisiemens. 5 millisiemens times 1 kilo ohm times I2. Okay. So now we take it to the other side and we'll find that Vy is I2 times 1 minus 5 divided by 4 millisiemens or 1 kilo ohm times I2. Okay. So now you look at what I1 is. You can see that I1 is nothing but whatever current is flowing here, or the negative of that, and that current is I2 minus Vy by 500 ohms. Okay. So I1 is Vy by 500 ohms minus I2, or minus 1 kilo ohm times I2 divided by 500 ohms minus I2, or minus 3 times I2. So G12, which is I1 by I2 with port 1 short circuited, is minus 3. Okay. Now earlier we determined G21 to be 3 and G12 is minus 3. We know that this is reciprocal, so that satisfies sanity check. If you know that it is reciprocal, we don't have to independently determine that, but just as an exercise I did that and now confirm that it is reciprocal again in another way. Now we have to find V2 to find G22. So V2 is nothing but the voltage drop across that plus the voltage drop across that, okay, plus this. So V2 would be 5 times Vy, which is 5 times minus 1 kilo ohm times I2 plus 1 kilo ohm times I2, that's the voltage drop across that, plus Vy itself, which is minus 1 kilo ohm times I2. Okay. So the whole thing comes out to be basically minus 5 kilo ohm plus 1 kilo ohm minus 1 kilo ohm, or minus 5 kilo ohm times I2. So G22 is V2 by I2 with port 1 shorted, which is minus 5 kilo ohms. Okay. This will be minus 5 kilo ohms. The next problem, you are given A and you are told that N is a purely resistive network. There are also some resistors outside, but the part with resistors, if you represent it as a 2-port, will be reciprocal, of course. Then you're asked to find what happens in B. Now, first thing to recognize is that network A and B, when you set the independent sources to 0, are exactly the same. Because if you set the independent sources to 0, this becomes a short circuit. So between 1 and 1 prime, you have 1 kilo ohm. Here also between 1 and 1 prime, you have 1 kilo ohm. Although it is split up as 0.5 and 0.5, you have 1 kilo ohm there. And if you open circuit this, on the other side also, you simply have 1 kilo ohm. Okay. So there are many ways of doing this. You can write the two port parameters for this network N and this network N and solve it. And the condition that you get from the reciprocity of resistive networks is that this N is reciprocal. But the easiest way to do it is define a new two port where this reciprocity can be applied. Okay. So first we know that this voltage here is 2 volts. It is 2 milliamp times 1 kilo ohm. Okay. So now if I think of this as my 2 port, let's say this is my 1 prime and 2 prime. The ratio of this voltage to that voltage, that is basically G to 1, which is given by 2 volts divided by 10 volts, or it is 1/5. Now whatever I have enclosed in this, the new 2 port I have defined is purely resistive and therefore reciprocal. Okay. So now what happens is that, let's say I remove this, I replace this with a short circuit and I apply a current source here and call this I2 and call this I1. So my G12 will be I1 by I2 with port 1 short circuited of the new 2 port, and this will be minus G21 or minus 1/5. Okay. So now that's exactly the situation I have. I have this current source across this 1 kilo ohm, which is 5 milliamps. Okay. My I2 is 5 milliamps. And on this side, I don't have to do anything. It's simply 1 kilo ohm across 1 and 1 prime. So I have 1 kilo ohm across 1 and 1 prime. So this will be my I1. I am just matching the quantities in this figure with that figure. So I know that this I1 in this direction is G12 times I2, which is minus 1/5 times 5 milliamps or minus 1 milliamp. So it means that basically 1 milliamp is flowing in that direction. So Vx, it's very easy. It's 1 milliamp times half a kilo ohm, which is half a volt. Okay. So Vx equals half a volt. That's the answer. Now in this case, you are given some combination of 2 port with some sources and resistors outside, and you are asked to find the Norton equivalent between 1 and 1 prime. Now this may look slightly different in that before you found Norton or Thevenin equivalents of circuits with circuit components. Now you have a 2 port, but the definitions are exactly the same. So you find Norton current by short circuiting between the relevant terminals and finding the current. So if you short circuit that and find the current in that branch, that will be the Norton current. Okay. So now this IN will be whatever is coming there plus whatever is coming from there, and we can treat the two separately because we have the port 2 of this short circuited through this, so some current will come out of this, and this is short circuited through here. So the current in this will be 14 volts divided by 10 kilo ohms is 1.4 milliamps. So all I have to do is find the short circuit current of this whole thing. Okay, and that's not difficult. So if I use the 2 port notation, let me do that. This is V2, which I have set equal to 0. So this is I2, this is V1, and that is I1. All I have to do is to write out the equations and eliminate the variables. Okay, first of all, I have the Z parameter equations. By the way, sometimes it may be convenient to convert the Z to Y and so on. I'll do it in the straightforward way. So we will write out the two port equations first. V1 is 8 kilo ohm times I1 minus 1 kilo ohm times I2, and V2 is 20 kilo ohm times I1 plus 9 kilo ohm times I2. And we have the external constraints. Because of the short circuit, V2 equals 0, and because of the source connected here, I1 is half a milliamp minus the current through this, which is V1 by 12 kilo ohms. I1 is half a milliamp minus V1 divided by 12 kilo ohms. Okay. From V2 being 0, we get I1 to be minus 9 by 20 times I2, and substituting that in the first equation, we get V1 to be minus 8 kilo ohms times 9 by 20 times I2 minus 1 kilo ohm times I2, which basically turns out to be minus 92 kilo ohms by 20 times I2. And I put that into this. So I1 is minus 9 by 20 times I2, which is equal to half a milliamp, minus V1 divided by, and V1 itself is minus 92 by 20, so 92 kilo ohm by 20 times 12 kilo ohm times I2. And if I take it to that side, I'll get minus 9 by 20 minus 92 divided by 20 times 12 equals half a milliamp. Okay. And this comes out to be, if I multiply this by 12, I get 108 over there. Okay. The left hand side will be minus 200 divided by 240 times I2 equals half a milliamp. So I2 will be minus 0.6 milliamps. So the current flowing this way is plus 0.6 milliamps. So the total current that flows here is 1.4 plus 0.6, which is 2 milliamps. Okay. So the Norton current is 2 milliamps, and the Norton resistance is found by deactivating the independent sources. So we have this current source open circuited, the voltage source short circuited, and we can find the resistance in here. Whatever resistance we find, that parallel with 10 kilo ohms, because 10 kilo ohms appears directly across 1 prime, is the net Norton resistance. And this one, again, we write the two port equations. So let's say this is I2 and this is V2. So the resistance looking then there would be V2 by I2. And let's say this is V1 and that is I1. Okay. So again, we have the same two port relationships. V1 is 8 kilo ohms times I1 minus 1 kilo ohms times I2, and V2 is 20 kilo ohm times I1 plus 9 kilo ohm times I2. Okay. We also have this constraint that V1 is minus I1 times 12 kilo ohm, because only a 12 kilo ohm resistance is connected to port 1, nothing else. Okay. So now, if I substitute that in here, I'll get minus I1 times 12 kilo ohms equals 8 kilo ohms times I1 minus 1 kilo ohm times I2. Okay. And if I take this to this side and that to that side, I2 will be 20 times I1. Okay. And I substitute that in here, so I'll get V2 to be 20 kilo ohms times I1, which is 20 kilo ohms times I2 divided by 20 plus 9 kilo ohms times I2, which simply turns out to be 10 kilo ohm times I2. So the resistance looking that way here is V2 by I2, which is 10 kilo ohms times I2 divided by I2, or 10 kilo ohm itself. So the net resistance is the 10 kilo ohm offered by this part of the circuit in parallel with this 10 kilo ohm, which gives us 5 kilo ohms. So the Norton resistance is 5 kilo ohms. Okay. And finally, this question here is, it shows two port networks connected in some way, and you can easily see that they are connected in parallel. Okay, and H parameters are given for one and G parameters are given for the other one. Okay, and you should find the Y parameters of the combined network. Okay, now if I call this I1A and I1B, okay, and let me call this V1 and I1. The voltage applied to port 1 of the first two port is V1, the second two port is also V1. Similarly, the voltage applied to port 2 of the first two port is V2, if this is V2, and this voltage is also V2. Okay, the same voltage is applied to the two ports, and the currents I1 will be I1A plus I1B. Similarly, if this is I2, this is I2A, this is I2B, I2 will be I2A plus I2B. So we have same voltages, currents adding up, so the two ports are in parallel. And you can see that if you represent both in Y parameter format, I won't show this, but you can easily write that and see the Y parameters of the two networks will add up to give the overall Y parameters. So the easiest way is to convert this H parameter to Y parameters, this G parameters to Y parameters, and move on. Okay. The way to convert from one parameter set to another is, first of all, let's say I'll take the H parameter example. We have V1 to be 1 kilo ohm times I1 plus 0.8 times V2, and I2 to be 0.5 times I1 plus 4.4 millisiemens times V2. So you have to rearrange these equations such that we will have I1 and I2 on the left hand side, and on the right hand side we have only V1 something times V1 plus something else times V2. Similarly for both equations. So I won't show the steps of doing this. The calculations is straightforward. You can go ahead and do that. I'll just show you the answers. So the Y parameters of the first network turn out to be this one. The Y parameters of the second one turn out to be that one. And we have to add the two to get the Y parameters of the overall network. So we get 1 plus 2.15, which is 3.15 millisiemens, minus 0.8 plus 0.25, which is minus 0.55 millisiemens, 0.5 minus 0.3, which is 0.2 millisiemens, and 4 plus 0.5, which is 4.5 millisiemens. Okay, so that's the solution to this particular question.